So this is going to be our next notes on Chapter 7 in Geometry, and we're continuing to talk about similar triangles or similar polygons. And we're going to revisit some theorems that we talked about. One is side, 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 and the other is side, angle, side. And we're going to first look at side, angle, side, and define it. And then we'll do side, 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 and then we'll look at some examples and we'll be done. So for side, angle, side, this theorem states, so if two triangles have two lengths that are proportional, only need two, but you also need the included angle to be congruent as well. So if we're looking at a triangle, let's just give you an example here. So I have a triangle here. If this is one side I'm looking to, and this is the other side, the included angle would be that one right there that connects them. Okay, so that's what we're talking about there. If those things are true between if the two lengths of two different triangles, so this one compared to another one's proportional, and this one compared to another one is the same proportion, and this angle is the same on these two different triangles, then they are similar. Another way to look at this is the side, side, side. So this just says, pretty easy one actually. So if corresponding sides of the two separate triangles are proportional, then the triangles are similar. And we're talking about all three. So like we have this one. So if AB is proportional to XY, and BC is proportional to YZ, and ZX is proportional to AC, or CA, I'm sorry, then this triangle is, these triangles are similar. They don't have to be the same size. They look kind of similar here, but they're not. But if those things are true, then they are similar. So let's look at some examples of how this works and how we can use it. So here we have these, couple triangles, one sitting on top of the other. And you notice I marked something here. We're going to do the side, angle, side one first. And because it doesn't give us any angles, but we remember this vertical angle thing here, this vertical angle theorem, that when we have these crossing over like this, these internal angles between lines, and these are called vertical angles, they're the same. So really we could draw a line right here and say they're the same. Then if we compare this line to this line, and this line to this line, they have the same proportion, then we're good. Okay, so let's go ahead and set that up. So if we do, how about we do RT, and we compare it to QR, and then we compare the other one, we'll do RS, and we'll compare that, this is one, and then we'll compare it to PR. These have to be the right sides. They have to be corresponding sides of triangles, ones that would be, corresponding to each other. So then we just plug in our numbers, right? So then RT is 12.5, and then QR is 5, and then we have RS, that is 20, and then we have PR is 8. Then we just need to get our calculator out and do the number crunching, see if they're the same. 12.5 divided by 5, that's 2.5. And the other one, 20 divided by 8 equals 2.5. It's correct. They are similar triangles. There's another way. We can do sides to see if they are congruent as well. So here we have a triangle. We can actually do ABC, so we'll do triangle ABC, and then we'll do triangle AFE, and see if they're congruent. So the first thing we want to do is pick some sides and see if they're congruent. So the first side we might want to do here is this side right here, okay, right here, and so we will go and do, so we're going to do AF, and we're going to compare it to AB, and then we can do the other side. So then we can compare AE, put that with the right triangle, right? AF and AE go together, so they go across, and then AB and AC. Okay, and we'll do our ratios now. So AF is 10, AB is 15, really, right? Because we got 10 plus 5. And then we have AE is going to be 8, and then AC is going to be 12. And then we plug these in 10 divided by 15. Show you the work. It's going to be 0.66 repeating. Hopefully the other one comes out the same. 8 divided by 12. Same thing. 0.66 repeating. Right? So they are the same. But here we don't have another side, right? So we actually have to fall back to our side, angle side. And we can do that because, look, they share this angle. So this little one has the same angle. It's like a reflexive property where they're overlapping each other. So this is actually a side, angle, side. And we can say that these are similar triangles. Okay. Now if we want to do the side, 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 we can actually go back to this triangle. I probably should have done that with this one, actually. Not worry about the angle, because we have another side, right? So we did QR, and we did compared that to RT, and we compared PR to RS, and how we do the last one? Let's do PQ to TS. So we go, and we'll go the other way actually, because we got this triangle on top, right? RT, RS, let's go TS on top, and then let's go PQ on the bottom. Got to make sure you do that. It's got to be, one triangle's got to be on top, the other one's got to be on the bottom. If you confuse them, you'll get wrong numbers. Okay, so here we have 15 for TS down here, and then 6 PQ, and then hopefully we get a 2.5 out of that. Looks like we will. 15 divided by 6, 2.5. So that's a side, side, side. And that's your notes. Add these to your notebook. We'll do a couple example problems in class, and I'll see you then.